Now let's turn our attention to wireless security. Now, wireless security is somewhat of an oxymoron with most administrators, but understand that wireless networking continues to grow in usage for two simple reasons, and that is convenience and lower cost. Now, wireless networking is extremely convenient. You buy a WAP, you plug it into your network, and you're offering wireless networking. It's very inexpensive, it's very easy for the users. They can bring any device in they would like and get internet access. And lower cost, you don't have to run wires or bridges or hubs or switches or anything like that. You just kind of put the WAP up there and let everybody go for the most part. And so this has really helped wireless networking along. However, wireless networking continues to be a serious security concern, although it's getting better with some of the latest technologies. Keep in mind, security issues have plagued wireless networking from the beginning. There's been a lot of attempts at security in the wireless realm, and they've proved ineffective. You'll see these on the exam. Just understand they do offer a layer of security, but they're not secure in and of themselves. We're talking about things like hiding the SSID broadcast. It's easily detected using software that you can download for free. A simple Google search will find these. Then there's MAC address filtering, where I'm going to restrict address to the wireless network based on a particular MAC address on a user machine. This sounds secure until you realize, once again, a quick search out on the internet, you can download free software that will basically spoof the MAC address and get you onto that network. So you need to be familiar with some of the wireless security standards that will be mentioned on the Network Plus exam. We're talking about WEP, WPA, WPA2, 802.1x. Let's talk a little bit more about each one of these. WEP, Wired Equivalent Privacy. This was the first attempt at wireless security, and this was introduced way back in 1997. Now, the idea was, what if we just encrypt the data, encrypt everything that goes between a particular computer and the wireless access protocol? Because keep in mind, anytime you're using wireless, anything that you send to the WAP is going everywhere as a radio transmission. So anybody else with a receiver can pick it up and take a look at your packets. WEP attempted to deal with that. Now, here's the problem with WEP, and it's been the problem with wireless all along. Everything has been designed for easy configuration and implementation. And that's great. And that's why wireless has been accepted the way it is. But it really, in a lot of ways, was done at the expense of security. And WEP did the same thing. It originally used 40-bit encryption. You can probably find sixth graders now who can crack 40-bit encryption. Later, this got updated to 128-bit, but regardless of the bit strength on the encryption, WEP was found to be very easily cracked using freely available hacking tools that you could just go out there and search and download and use. WPA came along, and it was called Wi-Fi Protected Access, and this provided enhanced data encryption. It kind of went another level. It utilized something called the Temporal Key Integrity Protocol, or TKIP. It scrambled the encryption keys from time to time using a hashing algorithm, and this made it more difficult for people to hack it. It also utilized Extensible Authentication Protocol, EAP, to control access based on a computer's MAC address. And so they kind of started layering things together here, but ultimately they found it to be much less secure than it was originally intended. And again, because of the fact that we're having to broadcast things back and forth, there was always ultimately little holes that could be basically exploited. And so WPA was found in the end to not be as secure as they originally thought. WPA2 then came along, and this one implements kind of the rethinking that's happened. It implements the full 802.11i security standards. It's not backward compatible with older cards and the way they functioned. TKIP was replaced with counter mode with Cipher Block Chaining Message Authentication Code Protocol, CCMP. Now, this added a lot more security to it. Now, WPA2 certification is mandatory for all new devices to be able to display the Wi-Fi trademark. Also, WPA2 is the current standard for wireless security. So watch for this on the exam. When you have choices between WEP, WPA, and WPA2, WPA2 is the most secure. It is the standard right now at this point in time. Now, you also might see 802.1.x mentioned on the exam. You also could see it mentioned as WPA Enterprise. This is a port-based network access control. It's not specifically designed for wireless networks. However, wireless works really well with it because what we're going to do is the port that we're plugging our wireless network into that connects us to the wired network basically utilizes authentication, and it's going to require an authentication server so that the user, before they can pass data through that port, they have to authenticate and receive authentication from that server, and it's applied to that port. And until the port's satisfied that it knows who you are, you're not going to be able to flow traffic through that port. Now, WPA Personal is kind of the personal home version of WPA Enterprise. It does not require a server, and it utilizes a pre-shared key, but it's still kind of the same thing. This is port-based, and we're going to have to satisfy security at the port level. We're kind of bypassing the WAP almost, but we're saying, hey, I don't care what the WAP says or thinks or does. You got to satisfy me before I'm going to flow data through here. Okay, so that's 802.1x or WPA Enterprise. So wireless security continues to get better. Make sure you're familiar with the options. You will see these mentioned on the exam.